everyone, I'm Daniel Ahmed Hernandez from the Plant Research Team together with Anissa Chua and Adrian Perry Aguiling from the Biomaterials Research Group of Plant Research Team and Tech for Good Challenge 2021. With our study on the synthesis of biopolymer using RMI or Rotten Mangifera indica for local industrial polymer production. Industrial polymer productions are one of the most abundant industries that remain active where materials synthesized are able to be utilized in different manners, such as to describe plastics, fabrics, rubbers, automobile parts, adhesive to sewer delivery systems, and even in modern engineering. Plastics are the leading material polymers, where additives are used in order to come up with a more structured material that is encountered in most applications of our daily living. This paper focuses on synthesizing biopolymer material from the Rotten Mangifera indica to determine its viability as a biopolymer material in local industry and to battle excess production and waste of mangoes in the local agricultural industry, adhering to the Sustainable Development Goal number 12 or responsible consumption and production. Pair experimental research design is used to create experimental samples and determine the physical-chemical characteristics and the statistical data. In this study, the RMI samples are divided into two separate preparations, a blended pulping and a juice extraction. Using alkaline pretreatment with 20% sodium hydroxide, experimental results from the study were analyzed using descriptive and inferential statistics, or primarily on using independent sample t-test using SPSS version 25. Experimental results shows that experimental sample of pair number 1, which is blended RMI with 20% sodium hydroxide alkaline treatment, exhibits a potent characteristics of biopolymer with a strength of 119.78 plus minus 50 pascals and an elasticity of 5,108.77 plus minus 4,403.21 pascals and a moisture content of 2.23 plus minus 0.58. This claim is supported by an independent sample t-test conducted between two experimental samples, blended RMI between extracted RMI at both 20% sodium hydroxide alkaline pretreatment, where it shows that there is a significant difference between the two samples in terms of elasticity, where the p-value is equal to 0.00 and alpha is equal to 0.05, wherein the p-value is less than the critical value of 0.0. Based on the experimental and statistical results, alkaline treated blended RMI yields promising viability of biopolymeric material in terms of tensile strength and elasticity and other related physical properties such as moisture content. Still, to further validate this experimental result, it is fully recommended to run more analytical tests that determine other significant characteristics such as thermal stability, structural composition, and integrity. Nevertheless, it opened the door of various possibilities in utilizing biomass resources into industrial materials for building sustainable communities and societies. This is Daniel Ahmed Hernandez from Plant Research Team saying imagine, innovate, and inspire. Thank you very much.